Hello and welcome back. We now have our game officially started on both the server and all connected clients. This means we can begin working on some actual gameplay elements of our game. Before we do, let's discuss how we're going to achieve this. For our game, each player will move his or her rectangle around the game window, trying to collide or hit other players. Each time they collide with another player, they will earn a point, and then they will be placed back at their starting positions, like a repositioning. Like they've earned their point, now they're back at their home base. Players will move and therefore change their coordinates. So what we'll do is we'll push those updated coordinates to the server, which will compile the new coordinates for all players into a single game state, and then push that game state back to each and every client. We'll then use that game state to draw the updated positions of every single player on each player's game window. The server is also going to work on the functions of computing the score, high scores, who's currently winning, and keep time, all of which are going to have to be pushed back to our clients. So with that in mind, let's head over to our client script. So here we are in our client script, and let's go to our player's update method. So we want to work on maybe moving the player around the board. So here is our player, and here is the player's update method. So what we'll do is we'll check to see if a particular key is being pressed right now or being held down. And if you recall, to check whether or not a key is being pressed is not an event. It is very different than trying to execute something on the actual pressing or releasing of a key. Those are Pygame events. But just saying like, hey, what keys are currently being pressed, you can get a list of all of those keys. And so let's actually get a list of all of those keys. So we'll check to see what keys are being pressed. So to do that, we'll simply call this list keys, and we call pygame.key.get pressed. And so this is going to return us a list, and inside of that list you're going to have a bunch of keys, and those keys, is it a list or a dictionary? It might actually be a dictionary. No, I think it's a list. Regardless, I'm not sure. It could be a list or a dictionary. But what will happen is you will, for each item in whether it's a list or a dictionary, you'll have a key name and then a value like 0 or 1. 1 is if it's being pressed. 0 is if it's not being pressed. So now that we have that list, we're going to just quickly make a rect for our player that is going to just help us kind of chart their movement. In particular, it's going to help us put movement restrictions on the player so it can't go off our screen. So we'll say create a rect to chart player movement. So we'll do player underscore rect is equal to pygame.draw.rect. We're not actually going to draw it at all. We're just creating it so we can put some boundaries here. We'll say display surface is the surface in question where we want this rect to be. The color would be our player's primary color or self.p color. And the position will be the player's coordinate, self.coord. Remember, coord is a starting x and starting y, and then a width and a height. And we have all of that in the player's coordinate. All right, so now we'll say only move the player if the player is playing the game, right? Because if you think about it, the player's update method gets called every iteration of the game loop. We don't want the player to be able to hit arrow keys and move the player when we're like waiting for other players to join or we're waiting for everybody to get ready. We only want to be able to move the player if the player is playing. So we're going to say if self.is playing. If that Boolean flag is true, now what are we going to do? Well, what we'll do is we'll check to see if a key is being pressed to move, and if it is, we'll change the player's dx or dy attributes to signal that we are going to change their coordinates in that given direction, either the x or y direction. And so what we'll do is we'll have a bunch of states here. I'll actually probably have 5 cases, one for moving up, one for moving down, one for left, one for right, and then the 5th one will be no movement at all. So maybe, no keys are being pressed, so we should stop moving. So let's see how we are going to do this. All right, so I'm just going to adjust something here on my second monitor really quick. All right, perfect. So if the player is playing, we'll first check the upstate. So we'll say if keys, that list, and if the element pygame dot k underscore up. So that's the up key. So if the player is pressing the up key and, right, so the player might press the up key, but we don't want them to move past the top of the screen. So we got to put some restrictions here. So we're going to use that rect that we created to help us with those restrictions. So and the player's rect dot top is greater than 0. Remember, for the y direction, we start at 0 on the top, and then as we go down, it gets bigger. So if it's like 15, well, that's greater than 0. We got room to move up. But if it's at 0, then we shouldn't move up anymore. We should stop. So what are we going to do? While moving up, we're going to say self.dx. We want no movement in the x direction. And self.dy, we do want movement in the y direction. We want to move up, so we're going to subtract the y value. So to do this, I'm going to do -1. That will indicate subtraction. And then how much do we want to subtract? Well, we have specifically designed the game such that the rooms are divisible by the player size. So, if the room is 600 and the player size is 60, well, then that's divisible. When you do that division, you get 10. So if I'm at the bottom of my game window, I should be able to move up 10 times until I get to the top. So we're going to move by player size increments. And so that's stored in our self.size. Remember, over here on the client right now, we're in the player class. So we'll reference the player just by using the self attribute or the self keyword. All right, perfect. So now let's do an elif. So elif keys square brackets pygame.k underscore down. And now we want to make sure if we're moving down, we're moving down, we don't want to move past the screen. So the bottom of our rect has to be less than our window height. So we'll say player underscore rect dot bottom is less than window height. All right, our constant variable window height that we got from the server. We'll say self.dx is equal to 0. We're not changing in the x direction. And self.dy is 1 times self.size. I could just write self.size. I like to put the positive 1 here just to kind of give me an indication that we're moving, up and down. Okay, wonderful. Now let's do the horizontal direction. So elif keys, what would it be? Pygame.k underscore left. We'll do left. And player rect.left. So now we should be able to move to the left until the left side of our rect. Remember, 0 is over here, so we want it to be greater than 0. Once it gets to 0, we can't move to the left anymore. Greater than 0. And so we'll say, now we're going to update the dx value. So self.dx is -1 times self.size. And we're not moving in the dy direction anymore, so we'll set dy to 0. And then we'll do the right, elif keys pygame.k underscore right. And we'll look at the rect, player rect.right. So if you think here, this has got to be less than our window width. And otherwise, we'll be at the edge of the screen and we shouldn't be able to move right anymore. So if that's the case, right, we're good to move. We'll say self.dx. And dx, dy, right, these are just like, I don't know, they're like calculus terms for change in x, change in y. So the change in x here is going to be 1 times the self size. So self.size. And the change in y will be 0. We're not changing in the vertical direction. And then lastly, what do we do if none of those keys are being pressed? Well, then we're just going to stop moving. So we'll say self.dx is 0 and self.dy is 0 as well. All right, so that's going to cover a lot of this method right here. I think that that's going to work really nicely. So now that we've processed the movement of our player, let's actually update our player's x and y attributes based on whatever the value of dx and dy are. So it'll move it in the direction we want to move into. So we'll say update the player's current coordinates. So we'll say self.x is plus equals self.dx. So if dx is, we wanted to move to the left, if it's a negative self size, so I don't know, like -20, we'll take their current x and subtract 20 from it. So that looks great. And we'll do something similar, self.y plus equals self.dy. And then let's update our coordinate. So self.coord, which we're using for drawing and comparisons quite often here, we'll say self.x, self.y, so our starting point in the x and y direction. How wide do we want our rect to be? It's self.size. How tall do we want it to be? Self.size. Awesome, awesome, awesome. So our player's update method, I believe, is complete. Now, the player will update since we're calling this method inside of our main game loop. So let's go down and look at that main game loop here really quick. So I'm going to scroll down. Here is my main game loop, and I'm calling my player.update right here. Now, there's nothing wrong with doing this here, and you don't have to do what I'm about to do. But I prefer to really only update and draw my game object. So I'm going to actually remove this right here. I'm not going to update the player directly. What we'll do inside of the game's update method, so you can see I have a mygame.update, I'll just call the player update from inside of the game. I just think it makes my game loop look a little bit cleaner, and I tend to like that. So now let's go to the game's update method. So let's scroll up. We're calling the game's update method. So let's actually work on writing this. So similar to the player, we only want the game to update if the player's is playing flag is set to true. So we'll say only update the game if the player is playing. So we'll say if. Now we're inside of the game object. So how do we access the player's is playing flag? We access the player first, self.player, and we'll say dot is playing. So if that is the case, we'll update the player first. And by calling my we could call my I guess we could call my player from inside of here, but instead we'll do self.player. I just copied and pasted that over. Inside of here, the player inside of the game object, the player is referenced as player. Outside of the game object, it was referenced as my player. But let's keep it as self.player.update, and now we'll update the game. So what do we have to do to update the game? Well, at this point, we don't really have to do much. I mean, we don't have to keep track of a clock on our end here and every iteration of the game loop, try to figure out how many frames have gone by, because we're not keeping track of time on our individual client. Rather, that's going to happen on the server for us, and we'll just simply get the time from the server. However, one of the things that we should do in our update method, and this is going to be important, every iteration of the game loop, we should check to see if the game has ended. Essentially, we should check to see if our round time attribute is at 0. So recall our game object has a round time attribute. Right? And so it starts as the round time that we got from the server, and then our goal is that we're going to decrement that by 1, every second. When it hits 0, well, that means the game's over. So we should do that in our update method. We should check for that. So we'll say if self.round_time equals 0, what do we need to do? Okay, so first, if the round time is at 0, means the game is over, or the round is over. So we should say self.player.isPlaying is equal to false. They're no longer playing, and they're not ready to play yet. So we'll say self.player.isReady is false as well, and just to ensure that. But what are they doing? They're waiting to play the next round. So we'll say self.player.isWaiting is equal to true. So you imagine when the timer hits 0, it's going to say something like game over, press enter to play again. When they press enter, what we'll do is we'll change is waiting to false, and we'll set is ready to true, and we'll monitor to make sure every single player is ready. And when every single player is ready, we'll set is false back, or is ready back to false, and we'll set is playing back to true. And again, we'll pump this all to the server. The server will collect it and send it back to us. Why don't we actually change our status message here? We'll say self.player.status message is equal to what do we want to say here? We'll just say game. We'll just say game over. I think for right now. Actually, let's say game over, and then we'll say enter to play again. So we'll actually prompt them to play again. Okay, so I think if we run this at this point, we should be able to sort of move our clients around and check everything out. So let's see if this is working. So server's listening. We'll run our client, and let's see if our player's update is being called correctly, and we can actually move around the screen. So we'll run. Okay, so we got our 2 windows open for a 2-player maximum. I'll hit enter over here. I'll hit enter And we've got an error. Of course we got an error. I've been making a lot of mistakes, so I apologize for this. Where is the error? Okay, so it's in my client file on line 89. It says list object is not callable. So line 89, so in my client file, line 89, right here. Oh, I made this mistake earlier in a video. I'm not trying to call self.coordinate. I want to assign self.coordinate a new value. I forgot the equal sign, which is a really just silly mistake. But we make mistakes, don't we? So I'll fix that right there. Again, some good debugging in real time. So let's run this again, and hopefully it's not the third time is the charm. Hopefully the second time is the charm right here. So let's see. We'll run it. We'll test it. And let's see if we can actually move our players. All right, press enter to play. Here's the other one. Press enter to play. I press enter, waiting, play. And so here I am moving my player quite nicely, and here I am moving my player quite nicely. So this is working pretty good. You may see a little bit of a lag. I think the lag is because my frames per second is pretty low. Let me up my frames per second on the server. Yeah, right now I'm capping the frames per second at 15. Let me put it at like 30 or something, and I think that will be a lot better. So let's just see. I'll run this. Server's running, client's running. Our next client is going to run. And now, essentially, we're telling Pygame, hey, the fastest you can run this now is 30 frames per second, which should be a lot smoother. So we'll hit enter, and now that's a lot better, I think. I'm a lot more happy with that. And over here, this looks pretty good too. Awesome. Now, if you notice, one of the weaknesses that we have right now is I can move on this client, but the movement isn't happening over here. So we've got to somehow get these two games to communicate with one another, which we're not really doing right now. Also, if you notice, like our original boxes are still here, and that's kind of a problem. It won't be soon, though, so we're going to change this. I think for right now, this is a really good place to stop for this video. And so in our next one, we'll continue working on some of our gameplay features. So I'll see you then.